you're streaming music, a file's downloading in the background, and it just works. It feels so smooth, but under the hood, it's absolute controlled chaos. Today, we're going to pull back the curtain and see how your computer juggles it all. And we'll start with a question that I know you've asked yourself before. We've all been there, right? The dreaded spinning wheel of doom. One app just completely freezes up. But here's the crazy part. Everything else keeps working just fine. You can still click over to your email or minimize a different window. So how is that possible? Why doesn't one troublemaker app bring the entire system crashing down? Well, the secret isn't in some complicated code. Not really. It's actually a brilliant system of organization. And to get our heads around it, we're not going to stare at circuit boards. Nope. We're going to take a trip into the fast-paced, high-pressure world of a professional kitchen. Trust me, this analogy is going to make everything make sense. Okay, first things first, we need to know what a process is. In tech speak, a process is just a program that's running. Your browser, that's a process. Your music app, yep, that's another process. In our kitchen, just picture a single chef, laser-focused on making one specific dish. That chef and that recipe, that's our process. Now, a process doesn't just pop into existence and then vanish. Just like an order in a restaurant, it has a whole life cycle. It goes through some very distinct stages. So let's follow one of these orders on its journey from the ticket machine all the way to the customer's table. So every single process goes through these 5 states. It all starts as new, that's the order ticket printing out. Then it moves to ready, all the ingredients are chopped and prepped, it's just waiting for a chef to be free. Running is the fun part, the chef is actively cooking, that's our CPU doing the actual work. Then you have waiting, maybe the dish is in the oven. The chef can't do anything else with it right now, they're just waiting. And finally, terminated. The dish is on the plate, served to the customer, and the job is done. Okay, so imagine a busy kitchen with hundreds of orders flying around. How does the head chef keep track of it all? You know, which steak is for which table, who gets the appetizer next? They don't just memorize it. They have that little order ticket. Well, in an operating system, that ticket has a fancy name. It's called a process control block, or PCB for short. This thing is basically the brain for every single task running on your computer. It's a neat little bundle of data that holds every critical piece of information the system needs to know about that process at any given moment. So let's break down that order ticket, our PCB. The dish name is just the process ID, a unique name for the task. The table number is like the memory pointer. It tells the chef where to find the ingredients, just like it tells the CPU where to find the process in memory. The current step is the program counter, literally what step of the recipe the chef is on right now. And special requests, that's the I/O status. Things like waiting for the oven to heat up. See? It's all right there on the ticket. All right, so a single dish, a single process, that's pretty straightforward. But a real kitchen and a real computer is a madhouse. It's juggling dozens of things at once. How does one head chef or one CPU core do it all without losing their mind? The secret is something called context switching. The magic behind multitasking is the context switch, and it's exactly what it sounds like. It's the act of the CPU pausing one task, carefully saving its exact state, all that info from the order ticket, and then instantly loading up the state of a completely different task and getting to work on that one for a little bit. Let's go back to our head chef. Picture this. They sear a steak for 30 seconds, then they spin around and chop veggies for a salad for 15 seconds, then they pivot again to stir a sauce for 10 seconds. They are switching so unbelievably fast, making these tiny little bits of progress on every dish that if you're watching from the dining room, it looks like they're cooking everything at the exact same time. That's precisely what your computer's doing. But here's the thing. This switching isn't just random. A great head chef doesn't just close their eyes and point to the next dish. There's a method to the madness, a strategy. And in the world of computers, this strategy is called CPU scheduling. This really is the million-dollar question for an operating system. You've got all these processes lined up, ingredients prepped, ready to go. Which one gets the CPU's precious attention right now? Is it the one that's been waiting the longest? The one that's fastest to finish? Or do you try to be fair to everybody? And there are a few ways to handle this. Let's look at 3 common strategies. You've got first come, first served. Simple enough, right? The first order in is the first one made. But what if a huge, complex dish comes in first? It could hold up a dozen quick and easy salads. Then there's shortest job first. This is way more efficient. The chef just knocks out all the quick dishes to clear the board. The problem? That big, complex dish might never get made. It could starve. And finally, you have round robin. This one is all about fairness. Every single dish gets, say, 2 minutes of the chef's time. Then they rotate to the next one. This way, you guarantee every single task is making progress. And this, right here, brings us all the way back to our original question. If one app freezes, if one chef gets totally stuck on a recipe, the scheduler just steps in and says, "Time's up." It performs a context switch, saves the state of that frozen mess, and moves the CPU's attention to the next dish in line. That one ruined dish doesn't stop the rest of the kitchen from getting food out. Now, just to give you an idea of the insane speed we're talking about, our chef isn't switching every few seconds. A modern CPU can perform a full context switch, stop one task, save everything, load up another, over 10,000 times in a single second. It's a level of task juggling that is just, well, it's hard to even wrap your head around. So it's clear our computers have absolutely mastered this art of context switching. They create this perfect illusion of doing everything at once. But it makes you think, doesn't it? We try to multitask just like our machines, juggling emails and messages and work, but it never feels that seamless for us. So it leaves me with one last thought. What if the next big breakthrough in our own productivity isn't a faster computer chip, but maybe learning a lesson from that chip, understanding when to switch tasks, and when it's better to just focus on one dish at a time?